So this is a birding case study of Hurricane Sandy in Ontario. This was 2012. It was an absolute hog of a storm, but I pulled this together in late 2012, and I haven't given the presentation in over 10 years, but I'm going to do my best to try to stick to the original messaging rather than change anything. While it was unfortunately destructive in a lot of places, and some of the bird watching, including what I was able to get out and see in Ontario, was truly remarkable. Any hurricane that comes into this part of the world is a big deal. Sandy was really interesting and maybe somewhat unique from the perspective of, it was a hurricane, but it was extremely large and had some features that aren't normally seen in storms anywhere, let alone our part of the world. Got the nickname at the time Frankenstorm with a lot of people in the weather community. So I'm going to dive into the history. That Frankenstorm has a few elements to it, but the one from the weather perspective is that it had characteristics of a hurricane. It was a hurricane. The core of the storm was warm core, but it also had a lot of features of an extratropical continental weather system. It was really, really, really large, and it was gaining energy from the ocean surface like a hurricane, but also through baroclinic forcing through these extratropical processes. This is kind of just an interesting piece, but it was almost 10 days before the event that the first computer model sort of spit out this shocking storm system moving into an unusual part of the world for late October. And I just happened to notice it. I posted it on my blog at the time and said, models are not accurate this far out, but boy, wouldn't that be crazy if that happened. That was the American global forecast model, and that was before the storm had formed. It wasn't until later on the 22nd that the storm itself, with its tropical process, formed deep in the southern Caribbean. That one model run seemed to be an outlier. It quickly disappeared off the GFS in subsequent runs. But around the time of formation, the European global weather model, which is also known for being quite accurate, also started to hint at that really unusual possibility of affecting the northeast US. Over the next couple days, the storm moved fairly steadily northward, gaining in strength, gaining in organization. It was sort of at a Category 2 or low-end Category 3 intensity. A couple days later, when it crossed Cuba, they officially upgraded it to a Category 3 at the end of season analysis, making it a major hurricane at that time. But interestingly, the Euro hadn't fully backed off of the crazy model runs affecting the Northeast, and a few model runs of the Canadian weather model were also starting to hint that something unusual could be about to unfold, but other models such as the GFS had totally backed away. So people were kind of keeping an eye on it, but it was still too early to tell. No consensus about what was going to happen. And so over the course of the next day, the storm pulled north of Cuba, passed through the Bahamas, passing over land, and then also hitting some cool continental air really affected that structure, the healthy structure of a hurricane. It is still a hurricane at this time, but you can see most of the powerful thunderstorms are really isolated to the northern part of the storm. It's being affected by shear. So it is gaining in intensity from a pressure perspective because the cold air is mixing with the warm air and adding energy and making the storm larger, but it's spreading it out. So that peak intensity in the core has come down. So that's a day later, and people all over the world are keeping a close eye on this because we don't really know where it's going to go at this time. Some models had it moving into the northeast, some had it turning and moving out over the ocean. Billion-dollar weather disaster or big waves, no worries, was pretty newsworthy at the time. But slowly and steadily, there were more models coming on board with the idea that something could happen. So time is steadily moving forward. Here's this monstrosity parked off the US East Coast. The storm eventually fought off the cool air, the first intrusion of cooler, dry air into its core, and started reorganizing. So still some baroclinic energy being interjected in the system, but the warm core had totally closed itself off again. Warm water of the Gulf Stream helping it to intensify. And it does actually, before it leaves the Gulf Stream, hit Category 2 intensity again. And at the time, here we are on October 27th, only a few days away from this disaster of a storm hitting the East Coast. But we do finally have model consensus where the American model, the European model, the other hurricane models, all have agreed finally that yes, in fact, this storm is going to take an atypical turn to the north, northwest, and then west into the United States. This sort of trough of cold air, cold front pulling in is going to stall out, and it's going to start to negatively tilt. So instead of being angled this way, it's going to start to become angled this way, and that's going to open a door for the storm to turn in this weird direction, because normally they are following the prevailing winds and they curve out to sea. So there's only sort of one thing left to do, and that was to get the word out that it gonna rain. And sort of as I mentioned earlier, with the cool air disrupting the storm but increasing its energy through multiple processes, the baroclinic forcing to inject energy, but also the hurricane core getting energy from the water, this whole second front is going to start to phase with the storm and make it stronger with lower and lower pressures and bigger wind fields as it makes this turn. Each of the model runs, slightly different, even a couple days out, but some of the potential solutions that are being presented are these like truly unprecedented in size and low pressure intensity for this part of the world. Like all-time records are on the cards. So this was my thinking at the time. Huge storm moving into the northeast. Initially, you can see these intense winds at the north end of the storm. They are going to rotate onshore. So even though the winds look like they die down as they move over land, that's largely just due to friction. Especially up off the ground, you're going to have these intense winds that pull things from this part of the world into this part of the world. But also the storm is just so unbelievably big. The circulation is so massive that where I am in Ontario, I've also really got my eyes peeled on the St. Lawrence Seaway, birds coming from Atlantic Canada down the St. Lawrence Seaway into Lake Ontario. After landfall, this sort of like frontal boundary from this baroclinic process is supposed to sweep over Ontario. So this is, early on at landfall. This is after landfall as the storm moves inland. And you can see there's now direct winds moving from, Long Island Sound, Cape Cod, curving overland straight to Lake Ontario. I'm living here at the time. This is where I'm planning to bird. So I sort of thought of this as phase 1 is birds coming from the St. Lawrence. Phase 2 is this rotation of birds inland. Phase 3 is this direct connection of the circulation right from the eastern US seaboard into Lake Ontario. And then phase 4 is this, even though the storm is weakening, the core, the central circulation, is then forecast to sort of drift north into the Great Lakes. So these are all different paths that I was wondering if I might see some displacement of birds from happening. So I put it to the test. I was so excited to put it to the test that I actually went birding from dawn till dusk on Lake Ontario and into Lake Erie for 6 days in a row. So day 1, I got out well before the storm was approaching land. It was still offshore in the Atlantic, but again, the circulation was so big that we had north winds and cloudy, rainy, windy weather. And throughout the day, even being really late October, I was excited and surprised to see species like flocks of sanderling and flocks of brant. And I associated this as birds coming from James Bay, coming from the Arctic, that were being grounded by that nasty weather. So it was a good kickoff. Day 2 is when I expected that St. Lawrence Seaway phase to kick in, so I was out at dawn, standing there watching all day. I maybe had less James Bay birds than I did the day before, and in fact, it was actually quite slow for most of the day, so I started to get some fears about what might be happening. But with about an hour of sunlight left in the day, I started to see black-legged kittiwakes. And with the winds coming right down the St. Lawrence from Atlantic Canada, including this flock of 6 birds right down the beach, the excitement level spiked. It's like definitely, no matter what happens from here on out, that St. Lawrence effect from this huge circulation was bringing unusual birds. And so that was October 28th and October 29th. And here just to kind of recap where we are, Sandy, this is the tropical storm force, like storm force wind swath, as the storm had started to make its turn when I left in the morning. Huge hurricane force wind swath. By the time I got home on the 29th, I was seeing that connection from Atlantic Canada into the Great Lakes. Saw some kittiwakes. I was kind of shocked that the storm had actually accelerated more than they'd forecast, and landfall was happening the night of the 29th. Which of course means I was pretty excited. I saw a lot of dark in the night because I couldn't sleep. But it happened. October 30th, 2012 was the day the Atlantic Ocean came to Lake Ontario. And I showed up at my birding destination, an hour before sunrise and total dark, and Obviously, I wasn't the only one excited since there were other birders there already. As it got light enough to see, we were treated to a raging lake with like 80, 90 kilometer an hour north winds. Boy, them birds started sweeping up the shoreline. There were kittiwakes in view, which quickly turned into flocks sweeping up the shore, groups feeding. They were in view at any time, which I took to be the compounding effects of that Atlantic Canada St. Lawrence Seaway circulation. But something else that was really exciting is we were still seeing more and more flocks of brant and sanderling. The initial phase of birds being grounded from James Bay or the Arctic was just compounding. It was just building. So we were seeing more kittiwakes from Atlantic Canada, more Arctic birds being grounded by the storm. It's not like you moved from one to the next phase and they changed over time. It just kept building and building throughout the morning. We had a particularly heavy band of rain late morning, and that was when the cell phones started pinging off that further up in Lake Ontario in New York, elsewhere in Ontario, a couple birders saw some pretty crazy things. So we were kind of waiting out the rain, and just as this heavy band of rain passed, the wind actually died down quite a bit and went from that stiff north wind to a sort of more moderate 40, 50 kilometer an hour east wind. And that was the shift. That was the kickoff of phase 3. That was the wind coming straight from the Atlantic coast in the United States onto Lake Ontario. And like almost instantly, Leach's storm petrel right up the beach. Now, I'll link the eBird checklist below, but just sort of kept building throughout the day. A couple more storm petrels, tons of birds from the north, tons of birds from Atlantic Canada. It blew our minds. So after a bit of sleep, with all the craziness that had been reported far and wide, everyone was pumped. We were jacked to get out on October 31st. The storm was weakening rapidly now that all the cold air is being mixed out with the warm air. There was no longer a hurricane over land, so there was nowhere left for it to go but slowly spin out. Throngs of birders descended all over the Great Lakes and elsewhere in the Northeast. Where I was in Lake Ontario, it was surprising that it wasn't very birdy. It was fairly light winds. It was sort of a gray, steady drizzle. Saw some cool birds, like this Forster's Tern is unexpected on Lake Ontario at the time, but it was kind of surprising to see it slow down. I was pretty happy to get probably my best ever picture of a brown creeper that day, but it was just surprisingly slow. But the phase 4 possibility with the remnant circulation moving into Ontario and into the Great Lakes was going to happen late in the day and throughout the night. So went home and tried to get some sleep. And with the wind switch on November 1st, it was with the circulation passing by us, the winds are supposed to really pick up out of the west northwest. So I repositioned to Fort Erie on Lake Erie, across from Buffalo, New York, and trying to utilize that stiff onshore wind that we were lacking the previous day to funnel some birds to shore. So pretty much as soon as I got there and set up my scope, there were Pomeranian Jaegers flying offshore. So we were back in business. Interestingly, we never saw anything definitive from that phase 4. I think the circulation had sort of fizzled out. There were some pretty remarkable birds that would have definitely been entrained in the circulation scene around Pittsburgh, Pennsylvania, and other locations only 100 and 200 kilometers away from where we were. But the birding was still pretty good nonetheless. That compounding effect that I mentioned earlier, where phase 1, birds grounded from the Arctic, birds from Atlantic Canada, birds from the eastern seaboard, whether it was Pomeranian Jaegers or long-tailed Jaegers or black-legged kittiwakes or flocks of brant, were around in huge numbers. It was super exciting. The highlight bird of the day was a Ross's gull. One was actually seen, it was 2 days earlier in upstate New York in the Finger Lakes. I'd like to think it's the same bird, but with the circulation so unbelievably massive and so many north winds being drawn into that part of the world, I think it highlighted how rare birds from the Arctic were conceivably brought to this part of the world by this huge, almost hybrid-like hurricane crashing into the Northeast. But yeah, it was really something. While I didn't get any pictures of the Ross's gull, unfortunately, it was a ways offshore. Another kind of interesting element was we saw some species like Sabine's gull or this black-headed gull fly by, which I almost wonder with some of them, they may have just been on Lake Erie. It kind of happens every year, but a storm not only has potential to bring birds in from multiple directions, but it also just sort of blows around the birds that are already there. So the list at the end of the day was pretty good, even if we didn't get any of those city terns or royal terns or Trinidadi petrels that we were hoping for. So I birded the next day and the next day onwards, but interestingly, the west-northwest wind that I mentioned pulled a lot of cold air down. It was November at this point, so we had this sort of stiff, cool northwest wind for a couple of days, and it was quite remarkable to see all of these unusual birds pretty quickly filter back out. Like I definitely got the impression that the kittiwakes and Pomeranian Jaegers were blown in and were still strong and healthy enough to say, well, I've got a good tailwind. I want to just get back to where I was. I want to get back to that saltwater quickly. So there are huge duck movements, huge migrations, but those really unique hurricane birds decreased in numbers pretty dramatically with each passing day. So I thought I'd just pull up these maps quickly. That's kind of the summary of what I saw. There's a lot of other things that people saw. You can read about in articles, etc., and so forth. But just to sort of revisit that notion of there were these sort of distinct origins from where the wind was coming from. North winds from the Arctic grounding birds and the wind and rain locally over a broad area. The connection from the St. Lawrence Seaway in Atlantic Canada kicked into gear. The connection from the east coast of the United States into the Great Lakes kicked into gear. And that circulation, birds entrained right into the core of the storm. They dropped out in this part of the world. They never quite made it far enough, but boy, was it exciting. It's an awesome case study. And I've got a couple of other sort of examples that I was going to touch on about historical precedent. Like, has this ever happened before? How do past hurricanes that have moved into the Great Lakes, compared to a storm like this? I think a really cool one that there's some remarkable bird records from places like Pennsylvania, 1954 Hurricane Hazel. It'd be interesting to see what would turn up today with our knowledge and know-how and number of birders who get out in the field. But here we are in sort of mid-October with this powerful Category 4, I believe, hurricane hitting South Carolina, moving over the Appalachians and into Ontario. It's famous in Ontario from the damage that it caused. Huge flooding in places like Toronto. Unfortunately, lives lost. But it wasn't quite as big. It didn't have that massive circulation. This was very much like a traditional hurricane that moved inland. And part of what really makes it famous from an Ontario perspective was it made that extratropical transition. It hit that cold front and got powerful, extra energy injected once it was quite a ways inland. So that extra energy and re-intensification as it lost its tropical characteristics caused a lot of damage. But I think it would have been really interesting to have a better idea of when and where the birds dropped out of the storm and if any, would have made it this far. Reading up, I think there was, Leach's storm petrels and possibly some white-tailed tropic birds in Pennsylvania. So definitely pushing birds, but not quite like Sandy. Another famous hurricane example locally was Hurricane Fran in 1996. So we're looking at early September. Powerful hurricane landfall at night, moves quickly over land, and then slows down quite a bit over the southern Great Lakes. So from an Ontario perspective, this one is pretty famous for the birds that it brought in. But again, it's definitely not like Sandy at all. This was a full-bore tropical system, its whole lifespan into Ontario before just sort of fizzling out in place. So what I think made Fran particularly remarkable for its black-cap petrels and oyster catchers and other southern or oceanic birds that it brought in had to do with that fizzle. I talked about how the circulation for Sandy with birds entrained in the core of the storm died out over Pennsylvania, and that's where a lot of the birds were dropped. I think Fran maintained its intensity into Ontario before fizzling in place, so that just allowed a lot of the birds to drop out where birders were ready to find them. But there's also sort of a second interesting element to, and that second element was Hurricane Huron, which is just this weird anomalous weather event that happened very shortly after Hurricane Fran moved into Ontario, where this stationary low pressure system really peaked in intensity in sort of a weird way. There's a Wikipedia page on it if you want to read about it, but I think the effect that this had was that it just kept it windy. It kept the birds moving around and moving to where people could find them, which is kind of something I learned with Sandy at the time, where just because the birds are there doesn't mean you're necessarily going to see them. You might actually still need a good wind to get them up and moving around. If they're tired or they're at a place, they might just sit on the water. making that detectability quite low. So Hurricane Fran not only dropped birds in the Great Lakes where there were lots of people ready and looking, but this totally, somewhat presumably unrelated weather system really enhanced the birding afterwards. Another interesting precedent I thought would be the perfect storm in 1991, which was this hurricane merging with cold air out over the ocean, which caused huge surge up and down the East Coast. That process of a very powerful warm core hurricane hitting seasonally cold air, causing this explosion intensity, followed by this sort of like recreation of a warm core afterwards with a hurricane almost tucked inside this larger continental weather system, is similar to how Hurricane Sandy got its size and intensity, but it stayed offshore the entire time. So, seabirds were probably being blown around by it, but they weren't necessarily brought to where birders might see them. So yeah, that's the story of Hurricane Sandy from a birding in southern Ontario perspective, at least my perspective, what I was testing in terms of weather theories, just the size of the circulation, the peak central pressure and intensity, really unlike anything that we've seen locally. After I recorded this presentation, I did actually have another storm that I thought might have made an interesting precedent. So I can link an article about that below if you want to read about it. But yeah, that was my story. That was my tale. It was really a remarkable opportunity for study as a birder, but also a ton was learned from the weather community about how the models were accurate. There was a lot of study afterwards to understand why there wasn't agreement earlier among them. This is all the times, every one of these white dots is the time a Hurricane Hunter aircraft flew through the core of Sandy. These are all the routes that they flew on those recon missions to collect data, to try and improve forecasting, to try and fix mistakes. It's pretty remarkable that with the investment at the time, how much more accurate we've become with predicting hurricanes. But yeah, it's quite the case study. So if you're keen on this kind of stuff, I'm slowly working away on this reference website. Otherwise, we'll keep our eyes peeled for other unprecedented weather events and see how it affects birds and bird migration. Otherwise, I hope to see you in the field.